Today we're discussing section 3.3 on analyzing graphs of quadratic functions. We're going to be talking about finding vertices and axes of symmetry, looking more at graphs of quadratic functions, and then solving some applied functions. So looking at quadratic functions of the given type, whenever you see this minus h and the plus k, you should think back to the last section 2.5, I believe, thinking that this minus h is a shift right by h units, and this is a shift up by k units. So when you have a quadratic function, we call it a parabola. Basically, it means it's of this format. It has a certain vertex that has been shifted right h units and up k units. We call that point, which we're of course going to represent with h and k, that vertex. So each graph has a line x equals h that's also the axis of symmetry. So naturally, if I have something where the vertex is down here, then I can split it down the middle by an axis of symmetry. And that, of course, is just going to be the line at whatever my x value is at. So notice my vertex has an x value -3, so my line of symmetry is simply x equals -3. Or you could look over here and see I have an x value of 1 for my vertex, and so x equals 1 is the axis of symmetry. Now also notice that whenever I have a U shape on my parabola, I have a minimum value, right? A minimum value of 3. The minimum value is my y value, and it's at x equals 1. If I have more of an N shape on my parabola, then I am looking at having a maximum value. And the maximum value, again, comes from the y value, which is, again, 3. So we're going to talk a lot about maxes and mins, and it's simply if I have a U shape, which notice is a positive coefficient in front of the x, then I know I have a minimum. And if it's an N shape, which I can tell if there's a negative in front of the coefficient in front of the x, then I know that I'm going to have a maximum. So we can look at something like this graph. The graph of g of x is x squared divided by 2 minus 4x plus 8. And we can actually just visually see what the vertex is, what the axis of symmetry is, and then of course what the minimum value is. It's really simple from a graph. So we can see that the vertex sits here at 4, 0. So the vertex is 4, 0. We can see that the axis of symmetry then is just going to be x equals 4, the vertical line. Matches up with the 4 and our x value in the vertex. Our minimum value of the function, well, that's the y value of the vertex, which is 0. All of that becomes quite simple when you're looking at the graph. When you're looking at it algebraically, it would be simple if your function was of the form f of x equals ax minus h squared plus k. Then it's really simple to pick up the h and the k. But we have to get our function to look like that. And to do that, we're actually going to use the technique of completing the square. So we have g of x equals, and I'm going to write this 1/2 x squared minus 4x plus 8. And we're going to, again, do that kind of same concept as completing the square. So what I need is a 1 in front of my x squared, not a 1/2. So I'm actually going to pull that to the very front of everything and factor it out of everything. Now, if I take 4 and I divide it by the 1/2 that I'm pulling to the front, I end up getting 8. You could put 4 divided by 1/2 in your calculator. And of course, I still have an x plus, and now I'm looking at the 8, and I'm dividing it by 1/2, again, to factor out a 1/2 to the front, and I get 16. Close parentheses. So now, when I look at this, I think first off, can I just factor this? Because we don't always have to use the completing the square technique. I think we'll see that actually in the next example. For this example, though, we can just factor it directly because notice 16 is a square. It's made up by 4 times 4. 4 times 4 also adds to 8. So I think this is immediately going to factor what we need it to be. 1/2, and then we'll think about factoring the rest. And see, I have a 4 times 4, and I need them to match in sign, so I have a -4. And look at that, we have our x minus 4 squared. So 1/2 x minus 4 squared. So that completing the square technique we don't have to do in this example. We'll see it in the next one. But we already got to our form that looks like this. There just is no plus k. Our plus k is 0 here. That means that our vertex is at 4, 0. Because again, h is 4, and there's a plus 0, which is our k. So there's our vertex. The axis of symmetry, then, we would have x equals 4 as the axis of symmetry. Again, I just pick up that x equals 4 right out of the 4 in the x position in the vertex. And then the maximum minimum value, well, I have a positive x squared term, which means I'm going to have a U shape like this, and the vertex is going to be at the bottom. That tells me I'm going to have a minimum. So not a maximum, but a minimum. And that minimum value is going to be, is the y value, remember, y value of vertex. So 0. That's it. That's how we think through these kinds of problems. Again, we are given this quadratic function, and we know we need it of the form at the top with the h and the k. So we do a little bit of factoring and notice that a square comes right out of this question as x minus 4 squared. So we know 4 is our h value and 0 is our k value. So we wrote down the vertex for h and k. Then we can write down that x equals 4 is our axis of symmetry because that's our 4 in the x value of our vertex. We know that our minimum value is the y value of the vertex, which is 0. We also know it's a min because it's a U-shaped quadratic. So that's kind of how these go. Let's see another example. So now looking at x squared plus 10x plus 23. So this is going to be our example with completing the square. And luckily, you're not going to have to go through this a ton because we're actually going to have a formula for this to find the vertex of this format in just a couple slides. So what is that I'm talking about? Well, if I want to find the vertex of f of x, and again, I want my f of x to be of the form a parentheses x minus h squared plus k. Then I want to take x squared plus 10x plus 23, and I got to make it look like that format. So what we're going to do is go x squared plus 10x plus a little bit minus that same little bit and then plus 23. So we're going to add a little something and subtract the same thing, which we can do because those two would cancel each other out anyways. And that's going to allow us to be able to factor this first part of the equation. The thing that we're going to plug in here comes from completing the square, which is where we add the b over 2 squared term. Notice for this example, in this example, we know b equals 10. That means b over 2 is 5, and b over 2 squared is 25. Therefore, our b over 2 squared term that we're going to add and subtract here, which comes from the same idea as completing the square, we're going to add and subtract 25. Then these three terms I can factor, and these two I can simplify. So to factor that first part, we write down x and our x, and we look and we're looking for two things that multiply to 25 and add to 10x. So we put in our 5s, and we know they're both positive. And then we simplify this next part. That's just a minus 2, minus 25 plus 23. Well, now we know we have x plus 5 squared minus 2. So now we can see our h and our k. But remember, this is of the form minus h. So this is really x minus negative 5 squared, because a minus and negative makes a plus. So we break that out, minus 2. So then we know that our vertex is negative 5, comma, negative 2. That also tells us then that our axis of symmetry is x equals negative 5. Now if we want to think about a minimum or a maximum value, remember that the vertex is minus 5, minus 2. And so we know we're thinking about something that goes like this, and here's the point. And I know it's a U shape because it's positive right here. There's no negative there. So it's not a max, it's a min, and the min is negative 2 because it's the y value of the vertex. So now we're going to see this actually graphed and verify everything we found so far. So notice our vertex, when we graph this function, negative 5, negative 2, great. Axis of symmetry is negative 5, and the lowest value that this function hits, negative 2. That's our minimum. You can also see that coming out of the table here. There's our minimum y value. All right, so the formula that I promised you, the vertex of any graph can be given by negative b over 2a, and then evaluating the function at negative b over 2a. Okay, so we calculate the x coordinate and we substitute the y coordinate into f. And of course, for these a, b, and c values, just come right from the function like we've been doing. So you might be given something like this. For the function negative x squared plus 14x minus 47, we're going to find the vertex, we're going to determine the maximum or minimum value, we're going to find the range, and we're going to figure out on which intervals is the function increasing or decreasing. So finding the vertex first. Let's think about our vertex formula, which of course is negative b over 2a, comma, f of negative b over 2a. And of course, with this vertex, our a value is negative 1, our b value is 14, and our c value is negative 47. So negative b over 2a is negative 14 over 2 times negative 1, which is negative 14 over negative 2, so 7. If I plug 7 into this function, I'm looking at f of 7, negative 7 squared, plus 14 times 7, minus 47. And if we get that into our calculator, then we have negative 49 plus 14 times 7 minus 47. We have 2. So our vertex is 7, 2. Now determine if this is a maximum or minimum value. Well, this function is negative in the front here, which means it's an N shape. So this is not a minimum, it's a maximum. Because we know the shape kind of looks like this, and here is my 7, 2. So the maximum value is 2, and it's at x equals 7, which also happens to be the axis of symmetry, of course. All right, now we got to think about what is the range. Well, it's helpful to think about, it's helpful to think about what the graph of this function actually looks like. So if this is my graph, let me make it a little bit more usable here. like this. Let's say here's around 7 and here's, I don't know, 2 is down here. So my vertex is at 7, 2, as we saw, and I know it's a negative, so I know it's going to look like an N. N for negative, right? So this is what my parabola sort of looks like. So if I think about the range, we can think, oh, well, it stops at 2, and it goes all the way down to negative infinity. So my range goes from 2 to negative infinity. Well, of course, we wouldn't write it like that, though. We'd write negative infinity, comma 2, putting 2 on the right. So, of course, we need parentheses with the negative infinity. And then with the 2, we do want to, include the 2, since the 2 is where the vertex sits. So it should be included in the range. It's a number that's hit by this function. Therefore, it's in the range, so we use brackets. So this is our range. Now we think about on what intervals is the function increasing or decreasing. So switch your brain back to x intervals. Before we were talking about y intervals, as in what's happening along the y-axis. But now we think about what's happening along the x-axis. Where am I increasing or decreasing? Well, I'm increasing from negative infinity all the way up to 2. We never include 2, the endpoint, in our intervals for increasing or decreasing. But then I'm decreasing. I go downwards from 2 all the way to positive infinity along the x-axis. So that's how we think about increasing or decreasing. It's really simple once you just kind of sketch the graph. I didn't even put too much thought into it. I threw down the vertex, thought about is it a U or an N, and you can easily pick up these questions. Now let's get into the real fun of this. So using these maxes and mins, we can actually answer really important questions about the real world. So for example, a landscaper has enough stone to enclose a rectangular koi pond next to an existing garden wall of the Smith house with 24 feet worth of stone wall. If the garden wall forms one side of the rectangle, what is the maximum area that the landscaper can enclose? What dimension of the koi pond will yield this area? So essentially it's like he has 24 feet to fill in this. Should he do something kind of long and skinny? Or should he do something kind of narrow and wide? Which one will give the biggest area? So that's what we're going to try to solve. Now looking at this picture, if we call this one W and this L, and here's another W, we know L plus W, right? WL, W, equals 24, the given total. And so if I want to figure out well, let's simplify this for a second. L plus 2W equals 24. If I want to figure exactly out what L is, basically how they got this 24 minus 2W, I'm just going to solve for L in this equation we have over here. So I have L equals 24 minus 2W. Just subtract 2W from both sides. Now we know that that's what this length is on the side. We also know the area of a rectangle is A equals length times width. Well, we have W here. We just figured out what length is. So our area is 24 minus 2W times W. Length, which we solved for above, times width. So length, we're just pulling from basically, it's whatever's left over after you put in of the stone after you put in the 2 widths, right? Length is what's left over from the 24 feet. So we stick that in as the length and we multiply by the width. And then if we simplify this, we get 24W minus 2W squared, which if you graph on an X and Y, it looks like this. So now we want to think about, let me see if we have more room. No, we don't. That's okay. Now we want to think about what is the maximum of this function. this area function that we just solved for? Well, you could look at the graph, which of course we're going to see 6 and 72. But if you grab our negative b over 2a formula that we have for the vertex, you'll see that we have negative 24 divided by 2 times a, sitting right in front of our w squared, negative 2, which is, of course, 24 over negative 4, so 6. So we know that our vertex sits at 6, comma, and now we got to plug in 6 to figure out the 72. Again, assuming we don't have the graph, we look at a of 6, which is 24 times 6 minus 6 squared. Oops, 2 times 6 squared, which is, in fact, 72. So we know our vertex 6 sits at, my goodness, 672. That is to say our maximum is 72. That's the maximum area. And then we know that our width is 6. That's our W that we solve for, feet. So our length, which is 24 minus 2 times 6, well, that's 12. So we know our length is 12. Now we know that our maximum width that we should use is 6. The maximum length we'll use is 12. And the overall largest area you can make with this shape is 72. And it really just came down to finding the vertex. All right, let's see another example. So for this one, we have a ball thrown directly upwards from a height of 8 feet with an initial velocity of 28 feet per second. That is to say that the height of the ball is given by this function here. Determine the time at which the ball reaches its maximum height and find the maximum height. So we got to find the maximum of this function. Let's start out by finding its vertex. So the vertex, this lovely formula, negative b over 2a, f of negative b over 2a. And we think about, well, a here is negative 16, b here is 28, and c here is 8. So our vertex, negative b over 2a, is negative 28 over 2 times negative 16. Well, that's negative 28 over negative 32. Both are divisible by 4, so that's 7 over 8. And then if we plug this in, we're looking at s of 7 over 8, which is negative 16 times 7 over 8 squared, plus 28 times 7 over 8, plus 8. Let's get this typed in a calculator. Negative 16, 7 divided by 8, 7 divided by 8, plus 28 times 7 divided by 8, plus 8. I know, it's such a surprise. I can't do this in my head. So this is 20.25, which is 20 and a quarter, which if we write as an improper fraction, 20 times 4 is 80 plus 1 over 4. 81 over 4. So that is the height, the max height reached by the ball. And it happens after 7/8 of a second. So yeah, kind of cool. We use math to describe what's happening physically. All right, another one. Here we have one component of a vertical file is to be constructed by bending the long side of an 8-inch by 10-inch sheet of plastic along 2 lines to form a U shape. How tall should the file be in order to maximize the volume that it can hold? And thank goodness they drew a picture here. So looking at that, we're taking a piece of paper and we're taking the 10-inch side and folding it into a U shape. So this side, and this need to add to 10, not to mention this and this are the same size. So this is also X over here. So taking that information into account, we want to find the maximum volume. So let's look here. We know that this side is X. And so we can calculate, knowing that these three need to add up to 10, we know X plus question mark. This is height, this is length. Let's call it width rather than using a question mark. That equals 10, right? Those three things need to add to the original length of the paper 10. So now we know 2x plus the width equals 10, which means the width is 10 minus 2x. So right along here we have 10 minus 2x. Okay, so now volume, which is length times width times height. Well, the length is 8 along here times the width we just found, 10 minus 2x, and the height is x. Well, simplifying this, we get 80x minus 16x squared. So I'm looking at 8x times 10, 80x, 8x times a minus 2x, minus 16x squared. And we want to maximize this. So we want to find the vertex. The vertex is negative b over 2a, comma f of negative b over 2a. Well, that's just, let's write out our a, b, and c's. I always recommend doing that. A here is negative 16, b here is 80, and c is missing, 0. So then negative b over 2a is negative 80 over 2 times negative 16. Let's write this actually up to the right a little bit. Negative b over 2a. That gives us negative 80 over 2 times negative 16. Okay, well that's negative 80 over negative 32, both of which I know are divisible by 8, so that's 10 over 4. We can go one more step and go 5 over 2. Yeah, just checking my work here. So negative b over 2a is 5 over 2, which now we need to look at what is f of 5 over 2. F of 5 over 2 is coming from our volume function. Remember what we're actually trying to find the max of. We're trying to find the max of volume, so we use the volume function. Let's write that down first. Our v of x is 8x times 10 minus 2x. So our v of 5 over 2 equals 8 times 5 over 2 times 10 minus 2 times 5 over 2. Really shoving it in the corner there. Well, that's just the 2 and the 8 make a 4, so that's 20 times 10 minus 5. Let's see, that's 20 times 5, so 100. Okay, so the x value, how tall the file should be, is 5 halves inches, which is 2.5 inches. That kind of makes sense. And the overall volume is going to be 100 inches cubed. There we have it. Now for the next one. Let's suppose we have the sum of the base and the height of a triangle as 26. Find the dimensions for which the area is a maximum. So let's draw a picture. Let's say we have a triangle like this. Here's the height, and here's the base. And we know the base plus the height equals 26. So if I wanted to write like one variable in terms of the other one, I know that the height equals 26 minus the base. Okay, so then we're going to use that and now think about the area function. Well, the area of a triangle is 1/2 base times height. So that's 1/2 times whatever my base is, times height, which I know is 26 minus the base. So that's 1/2. Let's go ahead and distribute 1/2 b to 26. That's 13b minus 1/2 b squared. And then we need to find our vertex. That'll tell us where the max and min of this function is. So that's negative b over 2a, f of negative b over 2a. And of course we need our a, b's, and c's. A is negative 1/2, b is 13, and c of course is 0. So if I look at negative b over 2a, that's negative 13 over 2 times negative 1/2, which is actually just 13. So the negatives cancel, and then the 2 and the 1/2 cancel, and we're left with 13. And so now we got to think about, well, what is our function a of 13? Make sure that looks like a 13. And that would be 1/2 times 13 times 26 minus 13, which is 1/2 of 13 squared. 1/2 of, well, that's 169 over 2. So the dimensions, though, that it's looking for, we know the base is 13. And so the height, well, the height is 26 minus 13 from over here. So we know the height is also 13. And that's the triangle with a maximum area. Now, I believe this is our last example. We have a profit example here, an economics example, really. So the profit of a company in dollars is the difference between the company's revenue and cost. The cost is C of X and the revenue R of X are functions for a particular company. And then X is going to represent the number of items produced and sold to distributors. So we're going to determine the maximum profit of the company and then determine the number of items that must be produced and sold to obtain that maximum profit. Now, of course, if you're a business owner, you would want to know how to maximize your profit given the revenue you can bring in and the cost of goods sold. So let's dig in. We know our cost is 2,000 plus 70x. Our revenue is 870x minus x squared. Those are both from the first page. And then we know that profit is revenue minus costs. So our profit function that we're trying to maximize is revenue 870x minus x squared minus our cost 2,000 plus 70x. Remember, cost has to go in parentheses. And so now we have 870x minus x squared minus 2,000 minus 70x. Combining like terms, we get negative x squared plus 800x minus 2,000. And so this is our function that we're trying to maximize. Now, of course, we look at negative b over 2a. You know what? I always do this. Let's write down our a, b, and c first. A equals negative 1, b equals 800, and c equals negative 2,000. Okay, so we look at negative b over 2a, and we have negative 800 over 2 times negative 1. Well, that's just 400. Now we plug it back in to find the actual maximum, which is p of 400, which is just negative 400 squared plus 800 times 400 minus 2,000. And if you put that in a handy dandy calculator, you get $158,000. So the max profit is $158,000, and the max, well, the number of items to obtain the max profits is 400. So just to be clear, the max profit is the y value of our vertex, right? The vertex we get here is 400, 158,000. So the max profit is the y value, and it happens when you have 400 items sold. So that is it for today. Thanks for listening, and as always, reach out if you have any questions.